Okay, it's going to be kind of a long one. Chapter 5, Section 3, talking about factoring. I'll make another video after this for special cases, actually. First thing to know about factoring is when and how to pull out the GCF, the greatest common factor. Whenever an expression has a greatest common factor, being able to pull it out, factoring out can be very helpful. Right now, these all have an x to the first as their greatest common power. So I know that I can pull out an x to the first from this trinomial. Then I look at these coefficients. The greatest coefficient factor these all share in common is a 2. So I also pull a 2 out. 2 goes into 4, 2 goes into 6, and 2 goes into 2. Since the leading coefficient is negative, whenever the leading coefficient is negative, you pull out a negative. You will do that every time your leading coefficient is negative. So I'm going to pull a negative 2x out of this trinomial up here. When I pull that out, I divide everything by negative 2x, basically. Negative 4x to the 5th divided by negative 2x becomes positive 2x to the 4th. 6x squared divided by negative 2x becomes negative 3x. Negative 2x divided by negative 2x is positive 1. You have to have that plus 1 in there. It's not a 0, it's not blank or nothing. There's a plus 1 there that you have to hang on to, and that has now been factored. You'll notice that all of these x powers just dropped by 1. So I pulled out an x to the first, essentially the same thing. So over here for the next example, the coefficients, the biggest thing they'll have in common is a 2, because 4 and 4 can't go into 18 and 6 can't go into 8. So I can pull out a 2. They don't all have an x in them, so I can't pull out an x, but they do all have at least one y. So I can just pull out 2y, and I'm left with 9x plus 6xy plus 4y squared. And that is now factored. When you have a difference of squares, we'll talk a lot more about this in a little bit, but if this thing here is a perfect square, and this thing here is a perfect square, and there's a subtraction between them, this only works for subtraction, not addition. I can do the square root of the thing on the left, and the square root of the thing on the right, twice. It becomes x plus 4, x minus 4, or x minus 4x plus 4. Whenever you see a difference of squares, square root the two sides, and those are your two factors. This will be 4x minus 7, 4x plus 7. And if this is like 16x squared minus 49y squared, or heck, even 16x squared minus 49y to the 6th, I apologize for just saying heck, that was inappropriate. That becomes 4x minus 7y to the 3rd, and then 4x plus 7y to the 3rd. I wasn't able to write those side by side because I ran out of space. But the point is, if this number here is even, if the power is even, it is a square. Okay, now we'll talk about factoring trinomials. When you have a quadratic trinomial, meaning that the biggest power is 2, and there's 1, 2, 3 terms, the quadratic trinomial, we want to factor this. One way that we've talked about factoring is by guessing and checking. Guessing and checking is the best way to try to start factoring and the best way to learn factoring, but it can take some getting used to. I start by drawing my two bubbles. And first, I know that these are going to multiply to x squared. So I want an x here and an x here because x times x is x squared. Yeah. Then I look at this c term. I want numbers that multiply to 6. Numbers multiply to 6 are 6 and 1 and 3 and 2, or negative 6 and negative 1 and negative 3 and negative 2. I want numbers that multiply to 6 but add to 7. Any numbers that multiply to this and add to this. Well, those numbers are 6 and 1. 6 times 1 is 6, so 6 plus 1 is 7. So this becomes x plus 6 and x plus 1, and that is now factored. If I were to distribute this, you would probably call that foiling. That's how I check. I can just check by doing x times x is x squared, plus 1x, plus 6x, plus 6, and I get x squared plus 7x plus 6, which is just what I started with, and that's a good thing, so my answer is good. When the things you're multiplying have some negatives in them, this gets a little bit more complicated. When the c term is negative, and the reason I'm calling that the c term is because remember in standard form, you have like ax squared plus bx plus c. So in this problem right here, the a value is 1, The b value is negative 5, the c value is negative 14. The sign is very important. When the c term is negative, you know that in these bubbles, one of them is positive and one of them is negative. That has to be the case because when they multiply together, you get a negative something. We also know these are both going to be pluses, so I want two numbers that multiply to negative 14 and add up to negative 5, and that's these numbers right here. So it's going to be x plus 2, x minus 7, and that is now factored. And that is very basic, simple factoring. You should be able to get a feel for that very quickly. They get much more complicated, and we'll deal with those a lot. One thing we can do is we can solve while we're factoring. If we're solving, then we're trying to find what x is actually equal to. Over here, I didn't care what x equaled, I just factored. Now I'm going to factor and find what x is equal to. There's a very important property called the zero product property. You don't have to know its name, but it basically says that if a times b equals 0, then we know either a equals 0 or b equals 0 or both. But something times something else equals 0. One of those two things must be 0. That only works for 0. That doesn't work for anything else. If a times b equals 2, then a could be 2 and b could be 1, or a could be 4 and b could be a half, or a could be a half and b could be 4. It could be anything. If a times b equals 2, we don't know anything about a or b. But if a times b equals 0, then we know either a or b must be 0. Well, that's an important idea once you factor. Because here it's like this is a and this is b. And so if a times b equals 0, I know that either this is 0 or that this is 0. So I can take those two bubbles, I call these parentheses, I call them bubbles. I can take those bubbles and set them equal to 0 and solve. So I found that x equals 3 or that x equals negative 2. So the point of factoring is partially so that you can get these a and b things, get these bubbles, and find what value of x gives you an equation that's equal to 0. Okay, when the a value is not 1, factoring gets much more difficult. When the a value isn't 1, I still know, I'm going to guess and check, that this needs to be a 2x and this has to be an x. Because 2x times x is 2x squared. And I still want numbers that multiply to 3. The problem is, whatever number goes in this spot right here, whatever number I'm going to put in that little spot, when I do the foiling to check, gets doubled. Whatever number goes in this spot gets multiplied by this 2 over here. So I really need these numbers to add up to 7, knowing that or to negative 7, excuse me, knowing that one of them gets doubled. And this is where it becomes guess and check. Is it 2x minus and x plus, or is it 2x, well, I guess these are both minuses in this case. This is a minus. Since this is a positive thing here, we know these are both going to be negatives because they have to combine to a negative number here. So is it going to be 3 and 1 or 1 and 3? That's basically the game we're playing at this point. Well, if I check the top one, 2x times 1 is negative 2x, and negative 3 times x is negative 3x, and 2x minus 3x is negative 5x, and that doesn't work. If I check the top one, well, I'll do the whole thing here. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Negative 1 times x is negative x. Negative 1 times negative 3 is 3. I put all that together, I get 2x squared minus 7x plus 3, and that is how it factored. Okay, so I factored that correctly. That's what I started with, so this factoring here is correct. I'm going to pause and try this next one in front of me. Here it's a positive 6 and a positive 7, so I know that I'm going to have 2x and x, and out here I can have 3 and 2, or 6 and 1. I'm not going to bother with negative 3, negative 2, and negative 6, negative 1, because I know I have to combine to a positive out here. And if I put a 2 here and a 3 here, that becomes 4x. That becomes 3x. 3x plus 4x is 7x. So it's going to be 2x plus 3 times x plus 2. Again, you can FOIL that to see 2x times x is 2x squared. We know that one's good. 2x times 2 is 4x. 3 times x is 3x. 3 times 2 is 6. 2x squared plus 7x plus 6. Well, that's not my answer. Excuse me, that was my check. Let me move back a step. That was my check. This right here is my factor form. I haven't solved any of these yet. We'll come back to that in a second. Okay, this is usually where I'd ask questions. I almost asked for any questions, but you know I can't actually hear you. So you can email me if you had them or just come to class. I'm going to show you how to factor by grouping now. Factoring by grouping has a lot of steps, and the steps are nice because they give you a formula that you can follow. The problem is there's a lot of steps to memorize. And the first step when you factor by grouping, this is a new method besides guess and check. This is a different guess and check, a method different than guess and check. The first step, whenever possible, is to always plot a GCF, which in this case is 2. And that 2 is just going to sit there for that whole entire process. This right now is step 1. Step 2 is to multiply A and C. That's my new A and C. This is A, this is C. A times C is negative 15. This was step 2. The sign is incredibly important. It's negative 15. I guess that was really step 1, because this was step 0. I'm already off, so I'll try and fix that. I could erase, but who's got time for that? Step 2, find a pair of factors of AC that add to B. This is a kind of the weird step, but it's useful. I'm going to write out every factor of AC. Negative 15 times 1, negative 5 times 3, negative 3 times 5, negative 1 times 15. That is every pair of numbers that multiplies to negative 15. I want them to add up to B. I want them to add up to 2. This pair right here adds up to 2. That's my magic pair, the negative 3 and 5. So now, this is the step that throws people off. My 2 is still just going to sit here. My 3x squared doesn't change. My negative 5 doesn't change. But then this middle term right here, this 2x, is going to turn into negative 3x and positive 5x. That's what this step here was. That was step 3. Is to replace the b term with the 2 factors from step 2. Well, 2x turned into negative 3x plus 5x because negative 3x plus 5x is the same as 2x. But these two numbers gave me something very, very useful. I can now cut the new expression in half, which means I'm going to go here, between this sign and this term. It's very important that that sign stays over there. I cut it in half. And I'm going to factor the 2 halves. This 2 still just sits there. My pen just got thicker, excuse me. Out of this group here, I can pull out a 3x, and I'm left with an x minus 1. Out of this group here, I can pull out a positive 5, and the sign matters, and I'm left with x minus 1. And these 2 bubbles are the same. If you've done your steps correctly, they will always be the same. If these 2 bubbles are the same, I put these into another bubble. So it becomes 2, the 2 still just sits there, 3x plus 5, x minus 1. This is the factor form of this. Now I think guess and check is the way to go, but I know that not everybody can guess and check. Another example. This one I'm going to solve when I'm done, so I'm going to go a little bit further. I'm going to do this one quite quickly. I know I'm moving pretty quick as it is. Factor out a GCF. Multiply A and C. Write out all the factors of AC. That's everything that multiplies to positive 12. Find the pair of numbers that add up to B, which is 7, and that's this. So now I have this. It doesn't actually matter which order these 2 numbers come in. You can actually switch them. And in this case, it's kind of nice if I do switch them, so I get things that can factor, but I'm just going to live with this the way that it is right now. I pull out so now I can factor the left half. All I can pull out of there is an x. And the right half, all I can pull out is a 1. This is important. I can only pull a 1 out of here, so I pull out a 1. The 1 actually matters because now I have this. Since these bubbles are the same, these 2 things combine. Here's the key. This is still equal to 0. It's equal to 0 the whole way. I need to actually solve this. I have to actually find what values of x make this true. get that x equals -1. Subtracting 4 from both sides, and 3x equals -4. So x equals -4/3. Those are my two solutions to that quadratic that we couldn't solve a couple days ago. That's factoring by grouping. One other way to show factoring, which some people really like and some people aren't too fond of, this is the exact same problem as the one before, 6x squared plus 14x plus 8. But one thing that you can do is what people call the diamond. You sort of just draw this x. I call it the x method, but some people actually put it in a diamond, which is why it's called a diamond, but diamonds don't look that bad. On top, you put a times c. You should always factor first, always plot a GCF first. You know, that's just a no-brainer. On top, I put a times c, which is 12. On bottom, I'll just put b, which is 7. I want to find two numbers that multiply to 12 and add to 7. That's 4 and 3. So I put a 4 here and a 3 here. These are the magic numbers. The whole point of that was just to pull out those two numbers right there. That blue's going to fade away in a second. Don't be surprised. Well, now that I've got that thing nailed down, I go into this little box. And in the top corner of this box, I put 3x squared. And in the bottom right corner of this box, I put a 4. But then these two numbers make up my other pieces. Instead of having a 7x, I have a 4x and a 3x. I can put those in either spot. It doesn't matter where I put these, 4x and 3x. Well, now I'm going to factor these boxes kind of by columns. It's sort of interesting. First I'm going to factor with my highlighter. First I'm going to factor this way. So from this first column here, I can pull out a 3x. Oops, that's not the right color. I can pull out a 3x. And from this column here, I can pull out a 4. Then I'm going to factor this way. Come on, this way. From the first column here, I can pull out just an x, and here I can pull out just a 1, and these become my parentheses. It kind of looks funny, but it becomes 3x plus 4, x plus 1. That is now factored. I didn't solve this one, but it is now factored. That diamond method that kind of leads into this lattice method does the exact same thing this one did. The goal of all this was to find the numbers 4 and 3, just like how the goal of this diamond was to find the numbers 4 and 3. It does the same thing, it just shows it in a different way. I do not care how you do it, I just care that you end up with this, and if you have to, you can solve from there. The problem with this diamond box method thing is if these are negatives, if this thing here is a negative right here in particular, if that's negative, sometimes both of these come out negative, and sometimes they don't, and it's really quite a big pain, and you have to play with it a little bit, but that's just something to be aware of. Okay, how'd we do? 18 minutes, sorry.